yesterday class we completed the exercise 3D. Now this is the new topic, adjoint and inverse of a matrix, and this is the topic that is related to the exercise 3E. Okay. So the first definition, adjoint and inverse of a matrix. So before these two definitions, first of all another definition, that is singular and non-singular matrices. The next definition, the first definition is singular matrix and non-singular matrix. Okay, the definition of the singular matrix is a square matrix A is said to be the singular matrix if det A is equal to 0. If its determinant is equal to 0, then the matrix is said to be the singular matrix. Okay, a square matrix A is said to be the singular matrix if det A is equal to 0. Example, suppose A is equals to 1, 2, 3, 6. Okay. Suppose A is equal to 1, 2, 3, 6. This is a given matrix. Now, is it singular or not? We have to check whether it is a singular or not. That is, finding the determinant value. What is det A? Det of 1, 2, 3, 6. Finding the det value. How to find the det value? AD minus BC. That is 1 into 6. 6 minus 3 into 6. 6. That is equal to 0. So, det A is equal to 0 means this is the singular matrix. Therefore, here A is the singular matrix. Okay. Now, what is the next one? Non-singular matrix. Non-singular matrix means det A not equal to 0. That is, for example, A is equals to 1, 2, 3, 4. Okay. A is equal to 1, 2, 3, 4. Now, is it singular or non-singular? Finding the det value, det A is equal to det of 1, 2, 3, 4, that is 1 into 4, 4 minus 3 into 2, 6, that is equal to minus 2, which is not equal to 0. Therefore, A is the non-singular matrix here. So, this is the non-singular matrix since det not equal to 0. Okay. So, singular and non-singular, these are the definitions. So, this is the non-singular matrix. Non-singular means det A not equals to 0. Okay, singular means det A is equal to 0, non-singular means det A not equal to 0. Now coming to the next definition, adjoint of a matrix. Okay, so first I take one matrix, let A be any matrix. Adjoint matrix is nothing but the transpose of a matrix obtained by replacing the elements of the matrix by its corresponding cofactors. This is called the adjoint matrix. For example, first I take the one matrix here. A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. For example, here I take one matrix. A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. For example, B is equals to cofactor matrix. Cofactor matrix means we have to replace all elements of this matrix by its corresponding cofactors. So, cofactor matrix means we have to interchange each and every element of a matrix by its corresponding cofactor element. That is, for example, capital A1 is the cofactor of the first element. Capital A2 is the cofactor of the second element. A3 is the cofactor of the third element. Okay. And B1, B2, B3. These are the cofactors of the second row elements. C1, C2, C3. These are the cofactors of the third row elements. Okay. So this is B matrix, cofactor matrix. Cofactor matrix means we have to change, we have to take the cofactor elements at the place of the elements of the given matrix. Okay. Now the transpose of this matrix B is called the adjoint of a matrix. Therefore, the adjoint of A is nothing but the B transpose. What is B here? B is the cofactor matrix of the given matrix. B is the cofactor matrix of the given matrix. Therefore, adjoint A is nothing but the B transpose. Okay. Adjoint A is denoted by ADJ of A. Adjoint A. Okay, listen. The next definition, invertible matrix. Invertible matrix means let A be any square matrix. So first we take here one square matrix. Now this matrix is said to be the invertible matrix if the matrix B exists such that, if suppose the matrix B exists such that A into B is equal to B into A is equal to I, then the matrix A is said to be the invertible matrix. So invertible matrix means if there exists a matrix B such that A into B is equal to B into A is equal to I, then the matrix A is said to be the invertible matrix. Okay, what is I here? This is the unit matrix of the same order of the A and B. What is A here? A means here we are taking the square matrix. Okay, let us recall the definitions once. What is singular matrix? Singular matrix means if det A is equal to 0, then the matrix is said to be the singular matrix. Okay, if det A is equal to 0, then the matrix is said to be the singular matrix. What is non-singular? Non-singular means det A not equal to 0. Okay, det A not equal to 0, then the matrix is said to be the non-singular matrix. And what is the adjoint of a matrix? Adjoint matrix means this is nothing but the transpose of the cofactor matrix. This is nothing but the cofactor matrix transpose. Okay, what is cofactor matrix? The matrix obtained by interchanging the all elements of the given matrix with its corresponding cofactor elements. That is called the cofactor matrix. Okay, cofactor matrix is nothing but the simply changing the elements of the matrix by its corresponding cofactor elements. That is, here adjoint matrix is nothing but the cofactor transpose. Okay, and the last definition, invertible matrix. Invertible matrix means a matrix A is said to be the invertible matrix if there exists a matrix B such that A into B is equals to B into A is equal to I, then the matrix A is said to be the invertible matrix. Okay, this is the definition of the invertible. This is the adjoint matrix. This is non-singular. This is singular. Okay, now by using this knowledge we can solve the all problems of the exercise 3. Okay, now let us start the exercise 3. And one more formula. The formula for finding the A inverse. Suppose A is the 2 by 2 matrix. Okay, suppose A is the 2 by 2 matrix. Then adjoint A is equals to, suppose A is equal to A, B, C, D. Suppose A is equal to the matrix A, B, C, D. Then adjoint A is equal to formula D minus B minus C, A. Okay, this is the direct formula for finding the adjoint A of the given matrix of the 2 by 2 matrix. Okay, if suppose one 2 by 2 matrix is given, then how to take the adjoint to that matrix? Just simply by applying the formula D minus B minus C. And what is A inverse to this one? To this one, A inverse is equal to formula 1 by AD minus BC into D minus B minus C. Okay, this is the formula to take the inverse of the 2 by 2 matrix. For example, A is the 3 by 3 matrix. Suppose A is the 3 by 3 matrix, then how to take the A inverse value? A inverse is equal to formula adjoint A by det A. Okay, this is the formula for finding the A inverse value. The formula is adjoint A by det A. Where we have the 2 by 2 matrix, and directly we can take the inverse by using this formula. If suppose the matrix is a 3 by 3 matrix, then we will apply this formula to get the A inverse value. That is, A inverse is equals to adjoint A by det A. Okay. Now these are all the formulas. Now let us start the next exercise. Okay, this is the exercise 3. The first problem, find the adjoint and inverse of the following matrices. The first question is cos alpha minus sin alpha cos alpha, and the second question is 2 1 to 1 0 1 2 2 1. Okay, two questions are given. We have to find the adjoint and inverse of the following matrices. Okay, let us start the solution. The first question, what is the answer? So first I take that the given matrix is equals to A here. That is, A is equal to cos alpha minus sin alpha cos alpha. So since this is the 2 by 2 matrix, now we have the direct formulas for finding the adjoint and inverse of the given matrix. For that, first I compare this matrix with the matrix A, B, C, D. Okay. First, I take that this matrix is equal to A, B, C, D. Then what is A value? Cos alpha. What is B value? Minus sin alpha. What is C value? Sin alpha. What is D value? Cos alpha. Okay. Now what is adjoint A formula? Adjoint A is equal to the direct formula D minus B minus C. Okay. So this is the formula. Now replacing the values. What is D value? D is equal, from the given matrix, what we have? The D is equal to cos alpha. Okay. Minus B. So B is equal to minus sin alpha. Minus B. Minus of minus sin alpha. That is equals to sin alpha. Okay. Minus C. C is equal to sin alpha minus C, that is minus sin alpha. A, what is the value? Cos alpha. So this is the value of the adjoint. Okay. Now the next one, A inverse. Now what is the formula for A inverse? A inverse is equal to 1 by AD minus BC into D minus B minus C. Okay. 1 by AD minus BC into D minus B minus C. Now replacing the values here. So this is 1 by, what is A value? Cos alpha. What is D value? Cos alpha. Cos alpha into cos alpha is equal to cos square alpha minus BC. B is equal to minus sin alpha, C is equal to sin alpha minus of minus plus sin alpha into sin alpha is equal to sin square alpha. Okay, into replacing the values. What is D value? Cos alpha. What is B value? Minus sin alpha minus of minus plus minus C minus sin alpha. A value cos alpha. Okay, but what is this when cos square alpha plus sin square alpha is equal to 1? Therefore the answer is equals to 1 by 1 into cos alpha sin alpha minus sin alpha cos alpha. Therefore the value of the A inverse is equals to, therefore the value of A inverse is equal to cos alpha sin alpha minus sin alpha cos alpha. That's all. This is the answer. Very important for 2 marks. This is a 2 by 2 matrix. Where find the adjointed inverse to the 2 by 2 matrix. Very important for 2 marks. Okay. Okay, so the next question, the second question is, so here also first I take that is equals to A. A is equal to 2, 1, 2, 1, 0, 1, 2, 2, 1. Now what is the given question? Find the adjointed inverse of the matrix. Okay. Now here we have one easy formula to find the cofactor matrix. What is the adjoint matrix? Since this is the 3 by 3 matrix, what is the formula for finding the adjoint matrix? Adjoint matrix is equal to cofactor matrix whole transpose. Adjoint matrix is equal to cofactor matrix whole transpose. What is cofactor matrix? Here cofactor matrix means here we have to interchange each and element of the given matrix with its corresponding cofactors. Okay. So to find the cofactor matrix, here we have one simple one shortcut formula. So to find the cofactor matrix, here we have one shortcut formula. Now I am telling that. Okay, listen all of you. So first I am finding the cofactor matrix. Okay. So first I am taking the cofactor matrix. Now this is the formula for taking the cofactor matrix. The formula is equal to, okay, all of you listen carefully. So first I take the second row elements. Okay, first I take the second row elements. So first I take the middle value 0, next last value 1, next first value 1, again middle value. Okay, understand? First I am taking the middle row values, middle value in this order, in the order middle value, last value, first value, again middle value. Now I am taking the last row values. Okay, second row, last row, again middle value, last value, first value, again middle value. Understand? Now I take the first row elements. Okay, middle value, last value, first value, again middle value. Again I am taking this row values 0, 1, 1, 0. Okay, writing the first row as the last row. Okay, this is the matrix. Now this is equals to, now taking the det values. Okay, just to take the det of these two, I am taking the integers here like that. I am taking the integers here like that. Okay, see 0 into 1, 0 minus 1 into 2, 2. That's all. That is the first element. Okay, 1 into 2, 2 minus 1 into 1, 1. That's all. That is the second element. 1 into 2, 2 minus 1 into 0, 0. That's all. That is the third element. Now coming to the second row, 2 2s are 4 minus 1. What is next one? 2 minus 4. What is next one? 2 minus 4. Okay. What is next one? 1 minus 0. What is next one? 2 minus 2. What is next one? 0 minus 1. Okay. Now this is equals to, therefore the answer is equal to minus 2, 1, 2, 3 minus 2 minus 2, 1, 0 minus 1. So this is the cofactor matrix. Okay, this is the cofactor matrix. matrix. Now what is adjoint A? Therefore adjoint A is equals to cofactor matrix whole transpose. Adjoint A is equal to cofactor matrix whole transpose. Okay, that is taking the transpose of this matrix, that is equals to minus 2, 1, 2, 3 minus 2 minus 2, 1, 0 minus 1 whole transpose. Now what is the answer? Writing the first row as the first column. So this is minus 2, 1, 2. Second row as the second column. 3 minus 2 minus 2. Third row as the third column. 1, 0 minus 1. So this is the adjoint of the given matrix. Okay. This is the adjoint of the given matrix. What is next? Also find the inverse of the matrix. Okay, sir. What is next? Also find the inverse of the matrix. What is A inverse formula? A inverse is equal to adjoint A by det A. Okay. So this is the formula for finding the A inverse value. Already here we have the adjoint A matrix. Now what we want? We want the value of the det A only. Okay, finding that value. Okay, listen. Given that A is equal to given matrix. What is given here? Det A is equals to. What is A matrix? This is the A matrix. What is det A? Det of 2, 1, 2, 1, 0, 1, 2, 2, 1. How to take the det value? Already I explained in the last class how to find the det value. Okay. So first taking the first element 2. Now leave the row and column in which the first element present. Now take the determinant of the remaining 4 elements. That is 0 into 1 is equal to 0. Minus 1 into 2 is equal to 2. Okay. Minus of second element. Minus 1 into. Now leave the row and column at which the element 1 is present. Okay, leave these two. Now take the det of the remaining 4 elements, that is 1 into 1, 1 minus 1 into 2, 2. Okay, now plus last element, that is plus 2 into, now leave these two. Now what is the remaining elements? Det value 2 minus 0, that is, this is minus 4, minus 1, minus 1, plus 1, plus 4 is equal to 1. Okay, therefore det A is equal to 1. Therefore A inverse is equal to, what is the formula? Adjoint A by det A. Okay. Inverse is equal to adjoint A by det A. That is, value is equals to adjoint A value minus 2, 3, 1, 1 minus 2, 0, 2 minus 2 minus 1, 5. Det A is equal to 1. Therefore, the answer is equal to minus 2, 3, 1, 1 minus 2, 0, 2 minus 2 minus 1. Okay, that's all. This is the answer. Understand?